Today's lesson is all about writing and solving proportions using mental math. Now, even though it says mental math, which I know a lot of you absolutely adore because, it's easier, I don't want you to think mental math means not showing your work, because that's not the case. It just means that we're not going to perform an algorithm or a process to figure this out. There's some strategies that we can use, just our brain power, to figure these answers out. All right, so the key when we're setting up and solving proportions is to be consistent. I cannot stress that enough. Be consistent. Let's look at example 1 and see what that means. All right, so we've got a chef, and they have this ingredients or this recipe here for black bean soup, tried and true, bestseller, and it has to have these measurements in order to be that fantastic black bean soup. Now, the thing with recipes is that they're made for, specific amounts of people. Maybe this is a recipe that serves 4, and the chef needs to make more than that. You can use proportions to kind of scale up a recipe so that, whenever you ask me, when am I going to use this in real life, proportions are definitely one that you'll use frequently. And this is an example. You're all going to need to make food at some point in time and likely going to need to follow a recipe. If you need to change how many people you serve it for, then proportions will help you out. All right, so chef increases the amount of ingredients in a recipe to make a proportional recipe. We want it to taste the same. We just need to change the amount that we make. The new recipe has 6 cups of black beans. We need to write a proportion that gives a number X of tomatoes in the new recipe. So here's the deal. In order for proportions to work, you have to be consistent with your labels. Now, I know that a lot of you don't like putting those labels on your numbers. Trust me when I say, if you want to get these questions right, if you want to understand and make sure that this is accurate, put your labels on there. It takes maybe, 2 seconds? An additional 2 seconds to do it, but you're going to be more accurate when you do that. Now, here is a structure or strategy to kind of help you out on being consistent. We're going to make a table. So I'm going to make a little bit of a table here. Kind of looks like a funky tic-tac-toe board. But what we're going to do is we're going to write those ingredients. We're looking at comparing black beans to tomatoes. All right? And we have, all right, black beans and tomatoes. We have the original recipe, and we have the new recipe. So original versus new. These numbers over here would be what's listed in my original recipe. And then what's in the problem would be what I need for the new. So black beans in the original recipe had 1.5 cups. We know that from right here. And then the original recipe, it had 1 tomato. So 1.5 cups to 1 tomato. In the new recipe, from the problem, we're given that it has 6 cups of black beans, and we need to figure out how many tomatoes we're going to need. We can take these 4 pieces of information and write a proportion by adding an equal sign, because a proportion is 2 ratios, and a ratio is comparing 2 quantities that are set equal to each other. And if we're consistent, see, look, there's a proportion hidden in there. 1.5 over 1 equals 6 over x. That's the proportion that we're going to need to set up and solve, and we'll do that here in a little bit. So 1.5, talking about black beans in the original recipe to the tomatoes in the new, over 6 cups of black beans and however many tomatoes we need in the new recipe. This is my proportion, and that's what we'll figure out how to solve here in a second. before we get going on figuring out how to solve how many tomatoes we're going to need in that new black bean recipe, we're going to go ahead and solve this proportion here. The 3 halves, or 3 over 2 equals x over 8, and we're going to use mental math. And just because it says mental math doesn't mean that you don't have to show your work, because you absolutely do. Now here's the beautiful thing. When we're dealing with proportions, that means that this 3 halves is equal to something x over 8. These two quantities are equal. Now you might say, well, wait a second, this 2 and this 8 aren't equal. Well, yeah, you're right, they're not, but we can do some math, either multiplying or dividing, to make 3 halves an equivalent fraction that's something over 8. So the mental math part comes into play when I say 2 times what equals 8? Well, that would be 2 times 4. That means to solve for x, I'm going to do the same thing. So 3 times 4 is going to give me whatever x is. Well, 3 times 4 would be 12. That means that x is equal to 12. And if we just take a second to think about it, 12 would be put over 8 in my proportion if I simplify that ratio. 12 divided by 4 is 3, 8 divided by 4 is 2, which gives me the same ratio that's listed on the left-hand side. Since those match, and we know that these two ratios have to be equal, I know that 12 is the correct answer. So x equals 12. That's what I'm talking about solving proportions using mental math. You still have to write down this whole arrow with the multiplying 4. That's part of showing your workspace. All right, now let's actually go ahead and solve the mystery tomato exercise. So we got to figure out how many tomatoes are needed. We had 1.5 cups of black beans for every 1 tomato. And I've got to figure out, if I have to have 6 cups of black beans, how many tomatoes am I going to have? Well, we got to think about this for a second. If I think about 1.5, 1.5 times what would be 6? Well, this one is kind of tricky, so let's just break apart those numbers for a second. If I think about 1.5 plus 1.5, that gives me 3. Okay, so 1.5 times 2 is 3. If I need to get to 6, I need to take that 3 and multiply it by 2 to get to 6. That means that this would be the same as 1.5 plus 1.5 plus 1.5 plus 1.5 to give me that 6, or 1.5 times 4. Now you probably were able to do that in your head. I just wanted to kind of break it apart and show you what I did. So 1.5 times 4 is equal to 6, so that means I have to do the same thing down here. 1 times 4 will give me how many tomatoes are needed. I will need 4 tomatoes to make a proportional recipe when I'm using 6 cups of black beans. Now, if this part kind of confused you and you're not sure exactly what Mrs. Banka did, let's take another route here. All right. If you didn't follow along with that mental math, let's look at another way to think about it. If I'm starting at 1.5 and I need to go to 6, that means I'm going to have to multiply by something, which also means if I had to work backwards, if I had to go from 6 to 1.5, I'm getting smaller, which means I'm going to divide. To figure out whatever I'm multiplying 1.5 by, see 1.5 times something, and we'll use x, equals 6. To work it backwards, this is a one-step equation, I'm just going to go ahead and divide by 1.5. Nose 1 out, so x is equal to whatever I'm multiplying by. I guess I should have used an m because it's different than what I'm finding. I just have to do 6 divided by 1.5. Move that over, Add a 0, 15 goes into 6 4 times. That's another way to figure out what you're multiplying by. Okay, that does it.